Okay, so good morning. Today I will give you the lecture from section 12.1. 12.1 is system of linear equations. We're going to solve linear equation using substitution and elimination method. And the notes which I'm going to follow are the notes from the PowerPoint. So just give me a second. Where's that PowerPoint? Let me open the PowerPoint. Okay, so you guys also have a section 12.1, the PowerPoint on Canvas. So 7 objectives. The first one, we're going to talk about solving system of equation by substitution. And then we'll focus on solving system of equation by elimination. And then we'll talk about different types of system of equations, which is and we're going to identify inconsistent and consistent systems. And then we'll focus on solving system with 3 variables, which is x, y, and z. And then we'll do some more problems. So this is section 12.1. So first, we're going to talk about solving system of equation with 2 variables. So when we're solving system of equation with 2 variables, so technically what we're doing, we're putting the equations of 2 straight lines, and we're trying to find the solution, which means point of intersection. So when we're solving system of equations which have 2 variables, at least in our section, because again, it doesn't have to be straight lines, but the one which we focus on is it's the one which are straight lines. So we're going to have 2 equations which represent the straight lines, and if we can find the point of intersection, let me just share it. Just give me a second. Okay, so we are here. So if we can see the point of intersection, that means we have one solution, which is just the coordinates of the point where 2 straight lines intersect. Just give me a second. Let's just pause that. Okay, so going back. So here, like you guys see, if 2 straight lines intersect, so the point of that intersection, we call it the solution. So this system has one solution. Now we can have a case when our 2 straight lines will be parallel to each other. So the system which doesn't have a point of intersection, we call inconsistent. And this system, which is inconsistent, has no solution. So the only case when 2 straight lines don't have solutions, that means they have to be parallel to each other. And we can have the third case when system is consistent and dependent. What that means that we have 2 straight lines which graphing exactly the same way, which you may think that one line overlap on the second line, which we have 2 equations of straight lines which are equivalent. They graph exactly the same way. So in this case, we have coincident lines, which means system, like you guys see in graph 3, has infinitely many solutions, because we have here we graphing 2 straight lines exactly the same way. So the solution of system of equation is the point of intersections. Since those 2 lines are coincident, they overlap, they graphing the same way, so we have infinitely many points as a solution of the system, which we call it consistent and dependent, infinitely many solutions. The first one, I forgot to mention, when we only have a 1 point as a solution, we call that system consistent and independent. Okay. So next, we're going to move to the first example, when we're going to practice graphing system of linear equations. So like you guys see, you have two straight lines. How you're going to know that it's a system? So we're using those extra fancy parentheses. So the first equation, the first straight line graph is 2x plus y equal -1. And the second straight line we're graphing is -4x plus 6y equal 42. So we're going to solve the system by graphing. Okay, so let me rewrite the first equation. 2x plus y equal -1. It's an equation of the straight line. I want to graph it. So I'm going to solve this for y. I will subtract 2x from both sides. And we will end up with y equal -2x minus 1. So I'm going to graph the first line. Again, it's a straight line, so it's enough that you have 2 points. Hopefully you guys recall the slope-intercept form mx plus b. So in our case, b it's -1, which is the y-intercept. So I know that I will have a point 0, comma -1, which is the y-intercept. The slope it's -2, so you can use that point to go 2 units down, 1 to the right, or just find the second point by replacing x with any number. So I'm going to make x equal 1. So y will be equal -2 times 1 minus 1. So we'll have a point 1 comma -2 minus 1, which will give you -3. So I'm going to graph, let's use it red, the first straight line using those 2 points, 0 comma -1 and 1 comma -3. Okay. This one shows you the solution, but again, let's just do entire work. So we have x, y. Let's make a unit. So I'm counting by 1. Okay, so the first one, which I have at 0 comma -1 and 1 comma -3, -1, -2, -3. Okay, so that will be the first straight line. Okay, so that's our first equation. Y is equal -2x minus 1. Since I'm solving the system by graphing, which I'm trying to find the solution, the point of intersection, that's why I'm rewriting each equation in slope-intercept form. So now I'm going to focus on equation 2. Let me see if I will have a space. So equation 2, we have -4x plus 6y equal 42. Solve this equation for y, so I'm adding 4x to both sides. So we're having 6y, it's equal 4x plus 42. Divide each by 6. And we will have the second straight line has the equation y, it's equal 4 over 6, which you can reduce by 2, so that will be 2 over 3x plus 7. So I'm going to graph the second straight line. So again, it's already in a slope-intercept form, so hope you guys see that one of the point will be point 0 comma 7, which is the y-intercept. That 7 represents y-intercept. So 0 comma 7, 1, 2, 3, 4, 5, 6, 7, right here. Okay, and to find the second point, again, you can make just x equal 3 or use the slope 2 over 3, but I rather to have a nice coordinate. So if x is equal 3, y will be equal 2 over 3, replace x with 3 times 3 plus, let's make it negative 3. So it's going to be 2 over 3 times negative 3 plus 7. So we're going to have a point negative 3, and that will be negative 2 plus 7, which will give us 5. Negative 3 comma 5. Negative 1, negative 2, negative 3 comma 5. 1, 2, 3, 4, 5. Negative 3 comma 5 right here. Okay, so this is our second straight line. Again, y equal 2 over 3x plus 7. And I'm going to extend the first straight line right here. And like you see, those two straight lines intersect at this point, which is negative 3 comma 5. And that point, negative 3 comma 5, it's a solution of the system of equations. So that's a point where two straight lines intersect. So you can solve the system of linear equation by graphing. It's not the best method. I would say not the faster method, because we need to graph it. We need to make sure that we graph it correctly and read the solution from the graph, which sometimes, if our graph is not clean or unorganized, sometimes it's hard to see that solution. So here on the fifth slide on your PowerPoint, you having that problem solved and explain it.
Done. I'm done.
Okay. So like you guys see, here we end up with the point negative 1, negative 2, negative 3, comma 1, 2, 3, 4, 5. So that's the solution, the point negative 3, comma 5. So that's the answer of the first problem. We solve system of linear equation by graphing. Okay. The next one, it's the example of solving system of equation by substitution. So here it's a pure algebra. So very important that you guys will learn the technique, how to solve system of equation using substitution. Okay. So with the substitution method, what we're trying to do, we're trying to avoid graphing. And we want to solve the system with the pure algebra. Okay. So you guys see, like previously, you see 2x plus y equal negative 1 and negative 4x plus 6y, it's equal 42. Which is the same problem like the one which we graphed. But let's just show you how to solve this system using substitution method. So what we're going to do, very important that you will mark the equation 1 with number 1 and equation 2 with number 2. So I'm going to start working with equation 1, which is 2x plus y equal negative 1, and I'm going to solve this equation for y. Why I picking variable y? Because it's very easy to solve this equation for y, because there's no number in front of y. So solve it for y. So we will subtract 2x from both sides, and we're getting y, it's equal negative 2x minus 1. Okay, and let's save it. So this is equivalent equation 1. Again, it's still the same equation 1, like here, but it's written in a slope-intercept form. Now what we're going to do, I'm going to move to equation 2, which is negative 4x plus 6y equal 42, and we're going to use the substitution. We're going to replace y from equation 2 with the equation of y, with the expression of y from equation 1. So we're going to replace y with negative 2x minus 1. Because don't forget that the solution of system of equation, it's the point which belongs to two straight lines. Okay, so let's use that substitution. So we have negative 4x plus 6, and we're going to replace y with negative 2x minus 1 with the y which we got from equation 1. And follow the rest. That's equal 42. So now when we're using the substitution, you're going to notice that equation 2 only has an x. We only have one variable, so we can solve this equation for x. So we have negative 4x minus 12x minus 6 equal 42. Combine like terms. So from here, we're getting negative 16x minus 6 equal 42. Let's add 6 to both sides. And that will give us negative 16x equal 42 plus 6, which is 48. Divide both sides by negative 16, and we end up with x equal negative 3. So that will be the x-coordinate of the point of intersection of those straight lines. Now to find y-coordinate, now we're going back to equation 1. Okay, so this equation 1, of course, and we know that y is equal negative 2x minus 1, and we're going to substitute. We're going to replace x with negative 3. So that's why that method it's called substitution. We're going to replace x with negative 3. So we have that y coordinate, it's equal negative 2 times negative 3 minus 1, and we have y equal negative 6 minus 1, which is negative 7. So the solution, like before, we're getting point of intersection x comma y, which is negative 3 comma negative 7. Oh, we got positive 7. Wait, that was the same one? Oh, negative. Sorry, guys. So that's 6 minus 1, which is 5. 5. And of course, double check your algebra. So we have negative 3 comma 5, which again, it's matching with the way we solve this system using graphing method. Okay, so it's the same system. Graphing method, it's nice if you want to see it, how the straight lines intersect. Here I show you how to use the substitution method. So quickly, let's verify. Substitution method. You're going to pick equation 1 or equation 2, it's up to you. I pick equation 1 and I solve this equation for variable y because it was just easier to solve it. So right here, you guys notice that I end up with y equal negative 2x minus 1. When I rearrange equation 1 for y, I went back to equation 2, which is negative 4x plus 6y equal 42. I replace y with negative 2x minus 1. When I use that substitution, my equation 2 changed to equivalent equation when we only had x as a variable. So I was able to solve this equation for x, and I end up with x equal negative 3, which means we already have the x-coordinate of the point of intersection. Now, to find the y-coordinate of the point of intersection of those two straight lines, I went back to equation 1, y equal negative 2x minus 1, and I substitute x with negative 3. And that gave me y equal 5. So we find y coordinate, y value, which represents the y coordinate of the point of intersection. So we have a point -3, 5. So what that means, we have system which is consistent and independent. Consistent means that you have a solution. Independent means, like you see, those two straight lines are independent. They're not equivalent to each other. They only intersect at the same point. Okay. So next, what I'm going to talk about it, I'm going to also, if I went too fast with explaining this problem, the PowerPoint give you the detailed explanation how they solving. Okay, so you can also check that. Next, we're going to talk about solving system of equation by elimination method. So first, let's read about how to obtain equivalent system of equations, because it's going to be very important, especially in elimination method. Elimination method means that we're trying to eliminate one of the variables so we can solve the equation, which only has x or y, and then we'll use the substitution. So first, what we're going to do, we're going to interchange any two equations of the system. Second, we're going to multiply or divide each side of equation by the same non-zero constant. 3, replace any equation in the system by the sum or difference of that equation and a non-zero multiple of any other equation in the system. So don't worry too much about that. I'm going to explain every single step here, what they mean using examples. So this system, next example, we're going to solve it using elimination. Okay, so elimination method. So the idea is, like you guys see, you have two equations, two straight lines. They have x and y as variables. So the idea is to start with the plan. So I want to eliminate one of the variable. So what I'm going to do, my plan is eliminate x. Why I pick x? Because two equations have the coefficients in front of x, which is 2x and -1x. They already have opposite signs. So I have +2 and -1. So to eliminate one of the variables, usually what you guys doing, you adding equations together. Elimination method, many times they call it addition method because we're going to add equations together. But before I add equations together, I want to eliminate x. So to be able to eliminate x, I need to have opposite coefficients in front of x. So we need opposite coefficients in front of x. Okay, so I have 2x and -1x, so it will be nice to have here in equation 2 -2x. So how we can do it? Okay, so to change equation 2 to have -2x, -2 in front of x, what we will need to do, we need to multiply equation 2, all the coefficients, everything, equation 2 by number 2. Okay, so look what happened. So I'm taking equation 2. I'm trying to build that opposite coefficients in front of x. So equation 2, which is -1x plus y equal -3. I multiply entire equation, which is the left and right side of that equation, by 2. So we're building equivalent equation. I'm not changing anything because as long as you did the operation on the left side of the equation and on the right side, we're still having that equal sign. So we multiply equation 2 by 2. So that will give us negative 2x plus 2y equal negative 6. So this is my new equation 2, which is equivalent to the original one. So next what I'm going to do, let's rewrite the system using equivalent equation 2. So the first equation, I'm going to copy without change. 2x plus 3y equal 1. The second equation, I'm using the equivalent equation, which is negative 2x plus 2y equal negative 6. So we have two equations. So now, when we have opposite coefficient in front of one of the variable, which is in front of x, next step what you're going to do, we're going to add equations vertically. We're going to add equations vertically. So we're adding equation 1 to equation 2. So that will give us 2x plus negative 2x plus 3y plus 2y. So again, like you see, I'm adding them vertically. It's equal 1 plus negative 6. So x's eliminate. That's why we call this method elimination. And we end up with 5y equal negative 5. So we eliminate x, and now we can solve the new equation by y, for y, and we end up with y equal negative 1. So we have y equal negative 1. So when you have that first variable, now the next step is substitution. So when we find that y is equal negative 1, the last step will be go back to original equation. I will select equation 2 because it's easy equation. So you can pick equation 1, it doesn't matter, but go back to original equation 2, which is negative 1x plus y equal negative 3, and replace y with, and substitute y with negative 1. Substitute y with negative 1 and solve for x. So we have negative 1x plus negative 1 equal negative 3. That will give us that negative x equal negative 3 plus 1, which is negative 2, which is x equal 2. So when we find x and y, the solution is the point 2 comma negative 1. So x was equal 2 and y is equal negative 1. So you always, if you're not sure if you solve it correctly, you always can replace x with 2, y with negative 1, and make sure that equation 1 will give you 1. And you can do the same thing. You can check your answer, substitute x with 2, y with negative 1 in equation 2, and make sure that you end up with negative 3. So if you're not sure, you can always check if that's the correct solution. So that was solving system of equation using elimination method. What is the difference between substitution and elimination method? Like you guys see, I work with equivalent equations. So I change equation 2 by multiplying left and right side of that equation by 2 to the equivalent equation, which was negative 2x plus 2y equal negative 6. And then I replaced that original equation to equivalent equation. And why we did that? Because when we add the equations together, x cancel. And we end up with a nice equation, which is 5y equal negative 5. We solved that equation for y, and then we went back to our original equation, replace y with negative 1 from equation 2, and solve it for x. Here again, this is the PowerPoint explanation, the same solution 2 comma negative 1. Okay, but also you have more detailed explanation. So this is for you guys. Next, what we're going to do, we're going to solve the word problems using system of equations. I'm going to use the example from your PowerPoint on slide 14. So this is movie theater ticket sales. Movie theaters sell tickets for $8 each, with senior receiving a discount of $2. One evening, the theater sold 525 tickets and took in 3,580 in revenue. So that's the profit which they made. How many of each type of tickets were sold? Okay, so here the last problem tells you what we need to find. They're asking how many of each type of tickets were sold. So we have two different types of tickets. So I will say X will be just regular ticket. And Y will be senior, the tickets for senior. So now we're going to, okay, numbers, not the price of case, numbers of regular tickets sold. And Y will be, just want to make sure that we're not talking about price here. Y will be the numbers, let's just put better, amount of seniors tickets sold. That's 9. Okay, so XY. Now let's gather the information. We know that regular tickets we sell for $8. So $8 price per one regular ticket. How much they sell senior tickets? So seniors receive a discount of $2. So that means $6 is the price per one senior ticket. Okay, so now we're going to to solve, since you have two variables, we're trying to figure out how many regular tickets and senior discounts tickets they sold. We need to create two equations. So let's build the equations. One evening, the theater sold 525 tickets. So one evening, they sold 525 tickets. Okay, so that means that part of the sentence tells you that regular tickets and senior tickets together, they sold 525. So X represents the amount of regular tickets they sold, plus Y. Y represents the amount of senior tickets sold. It's equal 525. Now, what also we know that the same night, the money, the profit, which they made, it's 3,580. So now we're talking about making money. So we have to include that 8 and 6 stars. So how we calculate the profit, the revenue, 358. So we know that one regular ticket costs $8. However, we don't know the amount of regular tickets they sold, so we're going to multiply that 8 by x plus senior tickets, they selling for $6. So $6 has to be multiplied by the amount of senior tickets sold, which at this moment it's y. So we're going to multiply 6 by y, and that will give you 3,580. So this is two equations. You have system of linear equation, and we need to solve it. How you want to solve it, it's up to you. You can use the elimination or substitution method. Of course, I'm not recommending graphing method. So what I'm going to do, I'm going to use the substitution method. So solve using substitution method. So I'm going to start working with equation 1, and I will solve that equation 1 for x. So we have x plus y equal 525. Solve for x, so subtract y from both sides, and that will give us that x is equal 525 minus y. So this is equation 1. Okay, so now let's work with equation 2, which is 8x plus 6y equal 3,580, and we're going to replace x with 525 minus y. Okay, so that will give us 8 times 525 minus y plus 6y equal 3,580. Distribute 8 to both. So we have 8 times 525, which is 4,200, minus 8y plus 6y equal 3,580. So that will give us, I will subtract 4,200 from both sides, and that will give us negative 2y negative 620. Divide each by negative 2, negative 2. So we're having that y is equal 620 divided by 2, we're having 310. So again, let's go back. Y represents the amount of senior tickets sold. So we already know the answer, that it will be 310. That's the answer. So now we have to find x. And how are we going to do it? Here, just go back to equivalent equation 1 and replace that y with 310 right here. So x will be equal 525 minus 310. So we're having 525 minus 310, and x is equal 215. So 215, that's the amount of regular tickets. Okay, so that was the word problem, and shows you how to use the system of equation using how to solve the word problems using system of equations. Okay, so we end up with the same solution, and you also have on PowerPoint detailed explanation of how they solve it. On the PowerPoint, they showing you how to solve this problem using elimination method, so you guys can compare. I solved this the same problem using substitution, but they solving using elimination method. On the test, it's going to be up to you how you want to solve system of equations. If you're a fan of substitution, you will be able to solve all of them using substitution. If you like elimination better, you will use the elimination. So next, what I'm going to do, I will go over of a couple slides. Here we're going to talk about identifying inconsistent system of equations. So inconsistent systems, that's the one which have no solution. Okay. So here you have example of inconsistent system of linear equations. So again, inconsistent means no solution. Okay, so how are you going to know that this system has no solution, which means the straight lines don't intersect? You can always graph it, however, that takes longer. But I'm going to show you how to solve this one using algebra. So we have to check what is the solution. So we'll do the same thing what we did before. We'll try to solve it. How am I going to solve this problem? I will use elimination method. So I want to review elimination method. So which variable I want to eliminate? In this case, I want to eliminate y. So you always want to start with the plan, eliminate y. And to be able to eliminate y, I should have in front of y from equation 1 the opposite coefficient. So the second equation has 2, so it will be nice to have -2 in front of y from the first equation. So what we're going to do, I'm going to multiply equation 1 by -2. So we're going to multiply entire equation 1 by -2, which means the left side and the right side. Everything is going to be multiplied by -2. So we're building equivalent equation 1. So that will be -2 times 2x, which is -4x, -2 times y, which will be -2y, equal -2 times 5, which is -10. Equation 2, I copy without any changes. So we're having 4x plus 2y equal 8. And now elimination method means addition method. Now I'm going to add equations together vertically. So I have -4x plus 4x, which is 0. -2y plus 2y, it's also 0, equal -10 plus 8, which is -2. So we end up with something what is fake. 0 is equal -2. So this is fake. This is not true. So what that means, this system has no solution, which means that two straight lines will never intersect. So the only case when lines will never intersect, that's when the lines are parallel. Those two straight lines are parallel. Okay, what that means, that this system is inconsistent. System has no solution means system is inconsistent. Okay. On the PowerPoint, you have the same problem using substitution method, so you can compare both. Now, here on slide 19, you guys see how equation 1 and equation 2, how they graph, and we end up with, like I mentioned before, two parallel lines. That's why you have no solution, because solution of system of equations should be point of intersection, so those straight lines will never intersect. Okay, so now we're going to talk about consistent dependent equations. Dependent equations, that means our straight lines, our system has infinitely many solutions. So we end up with two straight lines which graphing the same, so one line on top of the other. So how are you going to know that your system is dependent, which is consistent dependent? Consistent dependent means infinitely many solutions. Okay, so you're going to solve it at the beginning, the same way like we're solving any system of equation. You can use elimination or substitution method. Here, what I'm going to do, I'm going to use elimination method, and I would like to eliminate x. So I'm using elimination method. And my idea, my plan is to eliminate x. So to eliminate x, my second equation has negative 6x. So the first equation should have, in front of x, should have positive 6x. So we're trying to change equation 1 to have positive 6x. So in order to get 6x from equation 1, I need to multiply equation 1 by 3. So multiply equation 1 by 3, so we can have 2x times 3, which is 6x. Okay, so we multiply equation 1 by 3. So everything will be multiplied by 3, the left side and the right side. Okay, so equivalent equation 1 will be 3 times 2x, which is 6x, 3 times y, which is 3y, equal 3 times 4, which is 12. And I copy equation 2. So we have negative 6x minus 3y equal negative 12. Now, when you have opposite coefficients in front of x, we're going to add the equations together, and that will cancel, that will cancel, and that will cancel. So look what happened here. We end up with 0 equals 0, which is true statement. When your variables will cancel, that means your system, and you have a true statement like 0 is equal to 0, that means your system is consistent and dependent, which means we have infinitely many solutions. So we have infinitely many solutions. So how you can express that infinitely many solutions? There's a couple ways how you can express it. I'm going to work with original equation 1. You have 2x plus y equal 4. So what you can do, you can solve this equation for y. So you have y is equal negative 2x plus 4. So that's the only thing what we can do. We can solve for y. We can express y using x. And x is any real number. So this system has infinitely many solutions, and sometimes they express the system which has infinitely many solutions using that way. Just want to make sure I put in. Okay, so we copy the equation of y. Y is equal negative 2x plus 4, comma, x is a real number. Or you can do the same thing, x comma y, solve first or second equation, doesn't matter because they are the same, equivalent, solve for x, and that could be x equal we will move that 4. So we have 1/2 negative 1/2 y plus 2. And we'll say y is a number. So we'll just know this right here, that when you end up with a true statement, for example, the system is consistent, dependent, infinitely many solutions. However, on my MATLAB, they may ask you to leave the solutions either that way or that way. Okay, so how they got that solution? Again, here from equation 1, we solve the equation for y, and we're giving the conditions x is any real number. Or you can use equation 1 and solve it for x. So if you will do that, so if you will solve that for x, you will end up with 2x equal negative y plus 4 divided by 2, divide by 2, divide by 2. You will end up with x equal negative 1/2 plus 2. So you can express the solution, again, x comma y, like before. Just put it. So the solution is x comma y, such that, and we'll put that x is equal negative 1/2 y plus 2, and y is any real number. Okay, so there's 2 ways to represent the solution. And here what happened, on this graph, we graph equation 1, 2x plus y equal 4, and equation 2 together. And like you see, we have exactly one, or you may think those two straight lines, they're graphing the same. So the graph is dependent. Those two equations are equivalent. So that's why this system is consistent, because it has a solution, and every single point on that straight line is the solution. And we call that infinity. I think I will stop, because on next couple of slides, we're going to talk about solving system using 3 equations. Here we'll have to use more algebra. I will record the second video.